If you're asked to find equation of a line, typically you have 2 points. In this case, we have a point A and we have a point B. So to visualize it, you have a A and you have a B over here. Alright? So to link A and B, you would have a vector in which we have something like that. It should be a straight line, but anyway. So this vector, when placed onto A, point A, will translate point A to point B. This is generally the method of translating a point to another point using a vector. So how do we use this to find an equation of a line? The equation of a line that they mean is a line that is infinitely long. Okay, is from some infinitely n to another infinitely n. That's the meaning of equation of a line. And we are given these two information to help us determine this equation of a line. And how it's gonna work is, for example, let me share with you something. If I have a point, I call this point C. In order to translate point A to point C, you require a vector, right? I will say that the magnitude of this vector is 2 times of A to B, right? Because as you can see, it's somewhat 2 times of it. Then I would assume that if we have another point, let's call it D, okay? Perhaps hold on a while. Move the line to somewhere that is pretty wide. So I have another point, I call it point D, okay? So to translate point A, okay, to translate point A into point D, I require another vector, right? So this vector this vector A has the same magnitude as this vector A to B has the same magnitude from A to D, just as it's going in the opposite direction. That's all. So as you can see, any points that you set C or D will give you a different magnitude. This is the word magnitude. And with these findings, what we can do is to set out an equation that I would say that A plus a certain magnitude of a vector, okay, I will just write it over here first, is equals to a new point. Okay, so A is a point over here. When you add in a vector that has different magnitude, will give you different point. So I repeat again, if I have a point over here, I add in different magnitude of the vector, alright, in this case different magnitude of AB, I would have a different point. So if I have times 2AB, okay, if it is 2AB, then we will get to point C. If it's minus AB, then we are going into this DA, right? So this minus AB describes AD, and then this 2AB describes AC. Okay, I hope that this gives you a good understanding of the vectors, or a good recap back to vectors. Alright, so in this case, since we have 2 points already, we can straight away use in terms of AB in this case, right? And therefore I'll just take the assumption, not assumption but rather than the understanding, that point A plus a vector is equals to B. If I were to bring A to the other side, I have B minus A, and then I cancel off this dude over here. So in order to find AB, I need to use B minus A. Okay, this is the concept. So I use the point over here, 4, 0, 1 minus A which is 3 to 1, I would have 1, 0 minus 2 is minus 2, 0, 1 minus 1 is 0. And there we have a vector AB. And the magnitude itself, if it's 2 times, we will get C. We will have point C over here. If it's a minus 1 going in this direction, then we will have point D. Alright, so in this set, with this understanding, and after I clear things up a little bit, which is slightly later, I believe. So now, I would clearly say that this is an equation of a line. An equation that describes this infinite line all the way from all this chunk over here. Okay, this is the line that I'm talking about. Right? So you have a vector and you have 2 points. Remember. So I want you to actually remember the concept rather than remember the equation, so that it can help you to understand generally what the hell things are. And therefore, from this, then we can generalize an equation stating the equation of a line, which is any point A. In this case, I'm not talking about this point A anymore. I'm not talking about this dude anymore. I repeat again. So this point A plus lambda some AB vector. Okay, we're not talking about this B vector anymore. We're talking about general equation. Is equals to some R vector in terms of x, y, and z. So this is generally the key concept of our equation of a line. But for this case, this is a good equation of a line already. If they want you to put it in terms of a parametric equation, okay, actually I forgot to replace A in terms of its coordinates. Alright, so I'm gonna replace A is equals to 3 to 1 in this case now. Right, so I have 3, 2, 1. Yeah, so this is A, this is vector AB with a certain lambda is equals to some other points. So when you sub in different lambdas, you'll get different destinated points. That's the meaning of the equation of a line. Okay, and therefore, if you want to do a parametric equation, parametric, you can actually search. But if they want you to write in terms of parametric equations in the exam, you can take 3 plus lambda times 1 is equals to x, because R is in terms of x, y, and z. Alright, so 3 plus lambda is equals to x. 2 plus minus 2 lambda is equals to y. Sorry. And 1 plus lambda times 0 is actually 0. So I would say that z is equals to 1. That's all. So this is just a parametric equation because it's in terms of 3 lines in this case. In terms of, anyway, I'm not going to confuse things, but this is the form of a parametric equations. Alright, so this ends the part of equation of a line. Next video we'll talk about equation of a plane. I shall see you there.